1.4 Born-Haber cycle. This lesson we are going to define lattice energy and electron affinity and then explain the effect on the magnitude of lattice energy. Okay, there are two. One is ionic charges, another one is ionic radii. And then 3, explain the dissolution process of ionic solid. 4, construct Born-Haber cycle for simple ionic solid using energy cycle diagram and energy level diagram. 5 is calculate the enthalpy change using Born-Haber cycle. So first of all, we must know what is the definition of lattice energy. So there are two. One is lattice energy formation, another one is lattice energy dissociation. But normally we are applying the lattice energy formation. It's the energy release, means exothermic reaction. That's why the answer, right, for lattice energy of formation must with negative sign. When 1 mole of a solid ionic compound is formed from its gaseous ion. So this is the 1 mole of ionic solid or ionic compound is formed from the gaseous ion. Next is the opposite of lattice energy formation, which is lattice energy dissociation. We just reverse the equation. Now is the energy required to completely separate 1 mole of solid ion. 1 mole of solid or ionic compound into its gaseous ion. So the sign of the lattice energy dissociation is positive because this is endothermic. So you have to alert whether you are calculating the lattice energy formation or dissociation. As I said before, normally we are using lattice energy formation. Okay. The magnitude of lattice energy increase when the ionic charges increase because ions attract each other more strongly. The ionic charges mean positive 1, positive 2, positive 3. Means positive 3 is larger than positive 2. That's why the magnitude of lattice energy higher. Okay, the second factor is about ionic radii. When the ionic radii decrease, the size smaller, meaning that the distance between the nucleus and the valence electron get closer together. That's why the magnitude of lattice energy increase. So for example, this question between magnesium oxide and sodium oxide, which one more negative? Okay, we refer to the magnitude, okay, not the negative value, it's referred to the magnitude. Okay, the magnitude of magnesium oxide is more negative because magnesium 2 plus ion is smaller in size and has bigger charge than sodium ion. So the enthalpy of lattice energy of magnesium oxide is larger than enthalpy of lattice energy of sodium oxide. Next, what is electron affinity? The amount energy change, okay, change can be exo or endo, but over here, okay, normally is referred to exothermic release energy. Why? Because when an electron is added to a neutral atom, it will experience an attraction of nucleus. That's why it releases an amount of energy. So here, right, the definition amount of energy change, okay, this is for safe because not 100% negative. Later you will see why. Okay, so energy change to added 1 mole of electron, okay, added 1 mole of electron into 1 mole of gaseous atom or ion in their ground state and then produce an ion, because one you added electron, right, automatically you charge negative 1, okay. This is what I say. Electron affinity are generally negative. The higher or more negative the EA, the more easily it accepts an electron. However, affinity does not always release energy. That's why the definition using the term amount of energy change. Okay, not always release energy. In some cases, affinity require energy. For example, formation of oxide O2 negative. So for this one, second part, yes, EA is negative, but the EA2 means the second electron affinity is with positive. Here. Next. Okay, revision. What is ionization energy? The first IE is the minimum energy required to remove an electron from a neutral gaseous atom in its ground state. Just now is electron added. Electron affinity is electron added. Now IE is remove electron. So This is the first IE, minimum energy required. Second IE, right, actually I encourage you all write down minimum as well. It's the minimum energy required to remove an electron from a uni-positive gaseous ion. From here, this one we call it as uni-positive gaseous ion in its ground state. Okay, so they are now, after remove the second electron, it becomes at 2 plus ion in gaseous form. Okay, now we go for the main topic. Okay, this is one of the main topic of today's lesson. Dissolution process of ionic solid. Okay, it's a process by which a solid or liquid form a solution in a solvent. Occur when an ionic solid dissolved in water. So this definition we learned in 2.1 already. So the crystalline solid or ionic solid dissolved in water form the aqueous ion. Okay, aqueous cation, aqueous anion. Most ionic crystalline are soluble in water. Ion in the solid crystal can be separated from each other and converted to the gaseous ion. Okay, so for gaseous ion, right, you have to alert. Gaseous ion is involved lattice energy. Okay, this one is solution. Now, if the solid crystals separate from each other, become the gaseous ion is lattice energy. Okay, again madam ulang sekali lagi ya. Maksudnya sekarang tengok kat sini. Ini ialah solid larut dalam air jadi ion dalam aqueous. Yang ni yang enthalpy of lattice energy ialah solid. Okay, lepas tu dia bercerai ataupun pecah kemudian jadi ion dalam bentuk gaseous ion. Inilah perbezaan dia. Solution akan jadi aqueous ion. Kemudian kalau lattice energy benda yang sama tapi dia bercerai menjadi ion juga tapi bentuk gas. So aqueous ialah dissolution process ataupun solution process. Okay. And then kalau dia jadi gaseous ion ialah lattice energy. So the attraction force between gaseous ion and polar water molecule cause the ion to be surrounded by water molecule. So water molecule which involve is enthalpy of hydration. Okay, based on your lecture notes, this is the formula. Enthalpy of solution equal to enthalpy of lattice energy dissociation. Dissociation plus enthalpy of hydration. But previous one, we learned about, madam emphasized about lattice of enthalpy of lattice formation. So now I make a line here, meaning that I not encourage you all memorize formula, but I encourage you all memorize definition because based on understanding to form the dissolution cycle. So let's check. So based on here, right, based on this diagram, okay, so this is the sodium chloride solid. Okay, dissociate and then form the sodium and chloride gaseous ion. If dissolved is heat of solution from the aqueous ion. And then the gaseous ion dissolved in water form the aqueous ion. So now we check the relationship. Okay, we check. Notice that is like this. So if according Hessel's law, right, you know the destination is over here. If I put this one as A, this one is B, and then this one is C. So meaning that A plus B equal to C. That's why it's heat of solution means over here is C equal to A plus B. Okay, this is how the formula come from. Okay, but if we look at definition, right? Okay, definition, we will learn. Okay, the first definition we learn is lattice energy of formation. Okay, just now this one is dissociation. Okay, I prefer formation because later next topic we focus on lattice energy formation. That's why I don't want you all confused, right? We stick to one formation. So energy released when 1 mole of solid ionic compound is formed from its gaseous ion. So gaseous ion and then form the crystalline solid or the solid compound, solid ionic compound with the sign negative for the lattice energy formation. Another definition that is hydration, heat release, again negative sign, one mole of gaseous ion hydrated in water. Meaning that if you look at the equation, right, it's gaseous ion become aqueous ion. Okay, another definition is heat change. For the enthalpy of solution, heat change when one mole of substance. Okay, this substance dissolved in water from the aqueous ion. That's why now let's try one example. Okay, let's look at this example. Given that the data below, hydration of sodium ion is negative 2980 kJ per mole. Enthalpy of hydration of chlorine ion is negative 380 kJ per mole. And then the enthalpy of solution of sodium chloride is positive 6 kJ per mole. Then the question asks about calculate the energy cycle diagram to represent the dissolution process and of sodium chloride. Okay, first of all, you must know enthalpy of solution and enthalpy of dissolution is the same thing. Okay, the value and the sign still the same, positive 6 kJ per mole is the same. And then calculate the lattice energy of sodium chloride. Okay, look at this one. This is the answer scheme in your lecture notes. Okay, because this one is based on formula. Okay, based on formula, lattice energy equal to enthalpy of hydration plus enthalpy of hydration both ion plus and negative sign of enthalpy of solution. Okay, why need to put negative over here? Because you check, right? Hydration is gaseous ion become aqueous ion. So negative 390 for sodium ion and then negative 380 for chloride ion. And then here, okay, now it's initially the definition of this enthalpy of solution is 1 mole of crystalline solid or ionic solid dissolved in water and then form the aqueous ion. But do you notice that the arrow is reversed? That's why the sign positive 6 changed to negative 6. And this is the lattice energy of formation. For sure, the answer for this lattice energy of formation must negative value exothermic. Okay, so what is the relationship over here? You check. Okay, sodium gaseous ion form sodium aqueous ion and then form the solid chloride. So meaning that A plus B plus C equal to D. Okay, okay, that's why negative 306 plus negative 380 and then plus, okay, here you change signs already negative 6, okay, and then so straight away negative 6 so don't be confused over here. That's why madam dislike this method. Okay, madam dislike this method. I prefer you all form the energy cycle diagram according to definition. Okay, let's check. So sodium chloride, right? Okay, this is the enthalpy of solution of sodium chloride dissolved in water and then form the sodium ion aqueous and chloride ion aqueous with the sign of with the value and the sign of positive 6 kJ. Okay, this one remain the same, and hydration no problem. So now you check based on this energy cycle diagram, right? You check the arrow. Okay, you have to go to the same destination. So this is the final destination. Okay, sodium and chloride aqueous. Sodium and chloride ion in aqueous form. So this is the final destination. Meaning that, okay, the blue one equal to the red one. Okay, the blue one equal to the red one. This one is according to definition. And then you find the relationship according to the vector. Now, you know that lattice energy plus the enthalpy of solution is equal to enthalpy of hydration of sodium ion plus enthalpy of hydration of chloride ion. Okay, so if I want to find the lattice energy, meaning that is hydration of sodium and chloride minus enthalpy of solution of sodium chloride. That's why negative 390 plus negative 380 and then minus 6. So you get the same answer. So both methods acceptable, but you have to be careful. Okay, both methods are acceptable, but you have to be careful. So I prefer the second method because second method all follow the definition. For this one, not follow the definition. That's why when you form this, right? Okay, this is the reverse of the definition. That's why you have to change the sign over here. Okay, the concept still the same. If you are using this one, you have to follow the vector, means this A plus B. Okay, then you reverse the sign, become -6, so equal to enthalpy of lattice. Okay, so this is A plus B plus C equal to D. In this case, it's A plus B equal to D plus C. Okay, so you all about concept, all about vector concept. Exercise 2. Okay, again, the hydration of lithium, hydration of chloride ion is given, and then the enthalpy of solution of lithium chloride is given. And then the question asks about construct an energy cycle diagram to represent the dissolution of lithium chloride. Again, dissolution is equal to solution, and calculate the enthalpy of the lattice energy of lithium chloride. Okay, if the question either emphasize lattice energy of formation or lattice energy of dissociation, right? I prefer you all give the answer of lattice energy of this formation. Okay, formation. Yeah, formation with negative sign. Okay, look at this one. Okay, yes. Lithium gaseous ion react with chloride gaseous ion form the lithium chloride solid. So this is the enthalpy of lattice energy. Okay, enthalpy of lattice energy of formation. Okay, here is hydration. Okay, if you check over here, this is the reverse of enthalpy of solution. That's why just now the enthalpy of solution given is -77. Here, once you reverse the sign, it's become +77. So now the relationship here is A plus B plus C equal to D. Okay, that's why enthalpy of lattice energy equal to hydration lithium cation plus enthalpy of hydration of chloride ion, and then plus, okay, put the negative sign over here because you reverse already. So you have to reverse. Initially is -77, negative become positive. So this is refer to this concept. Okay, you have to refer to this concept. Okay, that's why here solution, right, heat of solution, we have to put a negative sign over here. But as madam said before, I do not encourage you all memorize the formula. I prefer you all form the energy cycle based on definition, meaning that madam will do like this. Okay, I will put like this. Okay, so here remain negative. Okay, now what is the relationship among these? So I put it as A, I put this as B, I put this as C, and I put it as D. Now the relationship is A plus B equal to C plus D. This is based on vector concept. If you're not sure vector concept, you can refer again. Okay, I refer Hess's law. And Hess's law, we never teach you about concept of vector. Okay, now A plus B means -510 plus -413 equal to C plus D. C just now is -77. So if you want to find the D, right? Okay, so you transfer to here. That's why it becomes +7. That's why the substitution and the final answer remain the same. Just the working here, you have to show up. Okay, plus, first you have to write down the relationship among the enthalpy. And then number 2, substitution. And then number 3, final answer with correct unit. Remember, must with negative sign for the enthalpy of enthalpy lattice energy formation, and the unit is kilojoule per mole. Please take note. So Born-Haber cycle, energy cycle for ionic compound. For example, just now KCl, KBr, NaCl, all other ionic compound. Connect enthalpy of formation with lattice energy. We have to find the link, the relationship between the enthalpy formation with lattice energy. How from lattice energy, and then link, and then finally they will connect again with lattice energy. So normally, right, when the question is given, right, the question might ask you find the lattice energy or enthalpy of formation or others enthalpy. Okay, so in this case, the question find the lattice energy by given this information. All of this is referred to the definition of the enthalpy of atomization, first IE and so on. That's why definition is very important. You must clear what is the definition about atomization, IE, EA, and enthalpy of formation. Let's check the answer. So based on here, right? Okay, potassium element and then chlorine molecule element and then form 1 mole of potassium chloride ionic compound. So this is enthalpy of formation. So based on the information given, the enthalpy value is negative 436 kilojoule. Then from the element, it will continue become potassium gas. This called as enthalpy of atomization. Okay, please check again what is the definition of enthalpy of atomization. Okay, from the element change to gaseous atom. Same for here, this is the atomization of chlorine molecule, enthalpy of atomization of chlorine molecule. So this is the symbol and then the value. After that, okay, after atomization, okay, for metal, it will form the cation by removing one electron. So this is IE. And then this is electron is added. So this one is EA. Then now here, change to the cation gases in gaseous form, and then chlorine anion in gaseous form, and then form the crystalline solid or ionic compound KCl solid. So here is the enthalpy of lattice energy. So formation, so lattice energy formation, right? Madam told you all before, is in negative value. So now, if according to Hess law, you check the relationship. Okay. See, if you follow the arrow, here will point to here. Same for here, connect to the same destination, pointed to KCl solid. Another is from here. So meaning that, okay, these, and these sum up will equal to this. Okay, so this is follow the vector concept as well. Okay, please take note. Okay, previous, the value given is in kilojoule per mole because that one is referred to 1 mole. But over here you write down equation already, right? The unit just kilojoule. When you form the energy cycle method, right, in Born-Haber cycle, all the unit just kilojoule. Without kilojoule, or you write it as kilojoule per mole, is wrong. And then the positive sign, negative sign for the enthalpy value insists. Okay, so quite rigid. If one of the point missing, then you will lose mark. And one more thing, phase, solid, gas, and then this one solid, insist. And then the balancing also insists. Okay, if the number of mole is wrong, then it's wrong. Okay, next you have to write down. This one seems like the formula lah. Okay, you have to form the relationships, meaning that from enthalpy is equal to the atomization of potassium, i.e. potassium atomization of chlorine molecule, EA of chlorine, and then join with the lattice energy of dissociation of potassium chloride, so equal to formation. So then substitution, and then final answer with conclusion. Insist negative kilojoule per mole. The final answer, the unit is kilojoule per mole. Please take note. So this is the way to answer Born-Haber cycle. Let's go for the other example. Okay, so now it's construct again. Construct Born-Haber cycle, magnesium fluoride, magnesium 2. Okay, so if you notice, right, all the value given here is kilojoule per mole. It's referred to 1 mole. But while you form the Born-Haber cycle, the value that you write down just positive 148 kilojoule. That's all. And then the final answer, okay, for the lattice energy is kilojoule per mole. Okay, this is the rules and regulation when answer this question. So now let's check the answer. Okay, the pattern still the same. Okay, magnesium solid, this is as element, chlorine molecule as element, and then form magnesium fluoride. Okay, this is the ionic compound. So this is enthalpy of formation. So this is the symbol equal to negative. Negative insists 1123 kilojoule, and then the phase insists. Next, the concept exactly the same, but magnesium, because there are 2 electrons, right? Sometimes the question will give magnesium to magnesium 2 plus. So one time is enough. If given magnesium, magnesium plus, magnesium 2 plus, right, you have to do it one by one. So this is the first IE. So this one is the second IE. Okay, and then don't forget phase, magnesium, gas, gas, gas. Okay, over here, because you need 2 fluorine atom, okay, so that can balance the MgF2, right? That's why just now potassium chloride we need to halve, okay, and then produce 1 mole of chloride. But over here we no need, because we need 2 mole of fluorine. Okay, sorry, we need 1 mole of fluorine molecule. Okay, and then undergo atomization, it becomes 2 fluorine atom. Okay, that's why from 1 mole become 2 mole. Okay, we have to check this one. This one now become 2 mole. And then the electron affinity here also become 2 mole. That's why we need to times 2. Okay, so this is the difference between potassium chloride and magnesium chloride. If from 1 mole become 2 mole, yes, we need to times 2. Just now is half become 1, still 1 mole. That's why we no need to do anything. Okay, we have to check the product. Okay, atomization is referred to the product. Okay, so again, formula substitution, final answer with unit. The concept is exactly the same. Negative sign, because for the enthalpy of lattice energy, enthalpy lattice energy formation is exothermic, negative sign, unit kilojoule per mole. Okay, madam, remind you all again. Make sure you can form the Born-Haber cycle correctly. The concept is formation, atomization, atomization. Yeah. Okay. Formation, enthalpy of formation, atomization, atomization. Atomization is in gaseous atom, and then IE for the cation, EA for the anion. After form the ion, gaseous ion, after form the gaseous ion, then join together is the lattice energy of formation. And then the lattice energy must in negative sign because it's exothermic. The unit for the final answer, kilojoule per mole. Okay, maybe some of you will straight away do the calculation without the substitution over here. No, please write down this one. Why? Because sometimes you might be careless, and then while you press the calculator, you get the wrong answer. So 1 mark might be given when you write down this formula or substitution. If your substitution is wrong, you still have the marks for the formula. Get it? Okay, next is about energy level diagram for Born-Haber cycle. Okay, just now is energy cycle, now is energy level. Level means level 1, level 2. Okay, so over here, right, in the Born-Haber cycle energy diagram, by convention, positive value are denoted as going upwards, and then negative value as going downwards. Let's see. Okay, consider the enthalpy change in the formation of sodium chloride. Okay, this is the first example for energy level diagram. So information given, formation, sublimation, then ionization, atomization, electron affinity, and lattice energy. You need to find the lattice energy. Actually, right, sublimation is like atomization as well. Okay, because from solid change to gases. So this is the answer. Okay, first, this is the final product, sodium chloride solid. Okay, so this is formation. So check. Okay, downwards because it's negative value. So next, atomization of sodium, positive value. Okay. If you check, when you are doing the atomization, enthalpy of atomization for sodium, right? Okay, then the half chlorine gases remain the same. Remain the same. Okay, over here is the formation of sodium chloride. Okay, then up again. So this one I think is atomization of chlorine atom. Yes. So over here the sodium gases remain the same. Okay, next. Okay, is the IE of sodium gases. Okay, here remain the same. That is electron affinity of chlorine atom. Okay, because negative, that's why downwards. Next is the lattice energy. As mentioned, lattice energy mass in negative value, that's why downwards. Is it finished? Not yet. Okay, because you haven't filled in the value for each enthalpy. You must fill in the value of each enthalpy. At the same time, remember, y-axis energy, and then E equal to 0 is started from here. You just put a sign over here because here is up and down. That's why E equal to 0 over here. And then up is positive value, down is negative value. Now try to assign the enthalpy for each of the value for each. Okay, started from here. Formation here. Formation negative value downwards. So equal to negative 411. Please don't forget unit kilojoule. And then this one, atomization of sodium is equal to the sublimation. Okay, from the solid become gases. So positive 108 kilojoule. And then the next is atomization of chlorine. So be careful, atomization of chlorine is here. Positive 122 kilojoule. And then what is the next? Now the next is ionization. Okay, ionization. So from gases, atom become gases, ion. Okay, ionization is here, positive 500. So equal to positive 500 kilojoule. Okay, and then the next is electron affinity of chlorine downward. So this one is equal to negative 364 kilojoule. Okay, and then the last one we need to find the lattice energy. So if you notice, right, is you just sum up all the value over here, you get the lattice enthalpy of lattice energy. And please take note, the arrow right must point from each from the bottom of the level until the top of the level, or from the top of the level till the from the top of the level to the bottom, or here from the bottom to the top. Okay, must touch the level. Okay. Don't forget the last part, calculate the enthalpy of lattice energy. So as usual, formula substitution, final answer. Your final answer must be with negative sign, and the unit is kilojoule per mole for enthalpy, lattice energy of formation. This is the summary for Born-Haber cycle. You must know the type of enthalpy relate with a Born-Haber cycle. So for example, it started from atomization, means from the element. Okay, change to gases atom. Okay, this one also the same. From molecule, change to gases atom. IE is the heat required to remove 1 mole of electron from gases atom to form gases ion. Must be 1 mole. Okay, if second IE, meaning that you have to remove 1 mole of gases, 1 mole of electron from the gases ion. If you still remember, it's positive ion to form 1 mole gases ion with positive 2 charge. First IE, heat release. Okay, when 1 mole of gases atom accept an electron to form 1 mole of gases ion with negative 1 charge. If second IE means you have to remove another electron from 1 mole of gases ion, okay, and then become negative 2 gases ion. Formation, okay, heat change when 1 mole of substance formed from its element, sodium solid, chlorine molecule. Okay, and then have to be careful this one, okay, Born energy, dissociation energy, or Born dissociation energy is referred to whole thing, means from fluorine molecule and then from 2 fluorine gases atom. So over here, right, the amount of energy required to break apart a mole of molecule into its component atom. So in this case, yes, from 1 mole become 2 mole, but we no need times 2, enthalpy given do not multiply by 2. Okay, so when the Born energy, dissociation energy, or Born dissociation energy is given, it's referred to whole thing already. Look at this example. Okay, just a short summary. Chlorine molecule and then become 2 chlorine atom gases. So this is atomization, right? So from 1 mole become 2 mole. Do we have to multiply by 2 if atomization? Yes. Okay, and over here the EF, 2 mole become 2 mole. Yes, because initially based on definition is 1 to 1, now become 2. We need to times 2 as well. Okay, if the question given is Born energy, if Born energy of chlorine molecule become the chlorine atom, then we no need time 2. Atomization, yes. Born energy, no. Okay, please don't be confused. Here is half mole chlorine molecule. Okay, over here, yes, because we want to balance the equation, we put half over here. But from half become 1 mole. So according to concept, still 1 mole. That's why we just stick to the original value, because 1 mole we no need times 2 or times half. No need. Okay, that's all for this lesson. Okay, please try your tutorial question. After you learn about dissolution process and Born-Haber cycle in energy cycle method or in energy diagram method, now you have to answer the tutorial question. Question number 18 and 19 is related with the dissolution process. You can try the vector method, okay, based on definition, or you can try to change the formula method. Also doesn't matter as long as you can answer correctly. And then 2021, you need to form the Born-Haber cycle. One is copper oxide, another one is magnesium chloride. And then question number 22. Okay, Born-Haber cycle is given. Now you have to answer the question according to this Born-Haber cycle. So what enthalpy change to enthalpy 2, okay, enthalpy 5, and enthalpy 7 represent. Please take note, even though this question seems like simple, right? Student might get it wrong because they just answer enthalpy of formation, that's all. No, you have to answer enthalpy 7 actually is equal to enthalpy of formation of calcium oxide. Okay, don't write down CaO, you must wording. Must write down in wording, calcium oxide, CalCiumoxide, be careful. And then calculate the enthalpy 5, and then calculation, and then question number D, I did mention. Okay, what is the factors will affect the magnitude of lattice energy? Okay. Okay, so there are 2 reasons. It's related with the size and charges. Explain your answer. Okay, and then objective question. Okay, please answer the objective question as well. Okay, you have to show the calculation. Okay, and then why you choose the answer as B and C, you must know. Okay, enjoy your weekend.